Let's now look at simplifying radicals. And remember that I told you at the very beginning that the square root of -1 is I. So anytime that we see a negative under a square root, we can pull that negative out as a -1, and then that becomes I on the outside of my radical. So we can rewrite square root of -49 as the square root of -1 times 49 under the square root. But we know that the square root of -1 is I. So I'm going to write I times the square root of 49. Now, the square root of 49 is the perfect square of 7. So my final answer would be 7 times I. Let's do another problem. This time I have the square root of -45, and so I can rewrite that as -1 times 45 and separate those two pieces. So this can come out to the outside. We're going to pop out an I, and that leaves me with I times the square root of 45. Now 45 is not a perfect square, but we have a technique for finding hidden perfect squares within things that are not perfect squares to start with. So I can break 45 into 5 and 9, and this is prime, so I'm going to circle it. 9 can be further written as 3 times 3, and those are both prime. Remember that we grouped things together that were pairs, so I have a pair of 3s, and then my everything else is a 5. So I can rewrite this as I to start with, and then multiply that by my 3 times 3, which is 9, and then multiply by the everything else, the square root of 5. And I know that the square root of 9 is 3, so I can rewrite this as I times 3, so 3I, and then finally a square root of 5. We can't do anything else with that, but we've simplified the radical because the number under the radical doesn't have any perfect squares left. Let's look at number 9. Number 9 says -2 times the square root of -100. So again, we can rewrite under the radical -1 times 100, and this -1 is going to come out to the front. So I'm going to have an I instead of that square root of -1. So that gives me a -2I, and then times 100. Well, 100 is a perfect square. This is a perfect square. So we don't have to do any factor trees in order to simplify this. It is simply a 10. So we can rewrite our equation as -2I times 10, and that gives me -20I. All right, finally, I would like for you to try number 10 on your own. So pause the video and then come back and see how you did. All right, so just like we've done in the other examples, we can rewrite the square root of -121 as the square root of 1, or -1 times 121. That square root of -1 comes out to the front as an I, and we're left with 121, which happens to be the perfect square of 11. So 6I times 11 gives me 66I, my final answer.